Hey guys, this is the video for 34 and 35. So let's do it. It says use the coordinates to compute perimeters of polygons and areas. Okay, so just for extra practice, I'm going to find the area, the perimeter, and the area of these things. And it says using the distance formula. Okay, now I almost never use the distance formula, but I'm going to jot it down right here, because they don't give it to you. You have to have it memorized. So that's the distance formula. What I normally use is this. So you might be thinking, well, how is that the same? Well, A is the length or the distance horizontally, and B is the distance vertically when you make an invisible right triangle. So it ends up being the same type of technique. So you might be thinking, what do I mean here? Well, for question number 1, it says, what is the area of the park? So let's find the perimeter. This is the park. And then we'll find the area, because the learning goal says they might ask either. So, okay, so the perimeter it's a 3-sided shape, so we have to add up all the sides. To find a perimeter, we have, if you can picture this invisible right triangle, notice that it's the hypotenuse. This length, AC, is the hypotenuse of that right triangle. So it's the hypotenuse of a 2 by 4. So that distance has to be 2, and then we're going to square it, right? 4, and then we're going to square it. And then that would equal to C squared. But we're going to take the square root because we want C. So this is what I call my shortcut. So AC is 2 squared plus 4 squared, and take the square root. So that's 4 plus 16. So that's the square root of 20. Now we notice here, it's the same invisible right triangle. This is also a 2 by 4 right triangle. So that would mean BC is also 2 squared plus 4 squared, and take the square root. Okay? Now, the last one, if I wanted to do the perimeter, I have to notice this is a 2 by 1, 2, 3, 4, 5, 6, a 2 by 6 right triangle. So this distance is 2 squared plus 6 squared. And that distance is AB. Okay, so the perimeter would be the square root of 20 plus the square root of 20 plus the square root of 40. And you could turn these into decimals, but you could also think of it as reducing these fractions. So this. Or reducing these so I get 4 times the square root of 5 plus 2 times the square root of 10. And you could turn that into a decimal. That would be the perimeter. So what would be the area? Well, we notice here that the slope of this, the slope of AC, is rise 2, run 4, and the slope of BC is fall 4, run 2. These are opposite reciprocals. So this is, in fact, an altitude, and we can find the area. Okay, so back to the job at hand. The area of a triangle is 1/2 base times altitude. So we could pick either side to call it the base. I'm going to call that one, right? It's the square root of 20. And the altitude, boo, splat. That one's also the square root of 20. So that would be 1/2 the square root of 400. That's 20. 20 divided by 2 is 10. There we go. So we found our area. But again, the learning goal said they might also ask the perimeter. So I did that. But my area is 10. Cool. Question number 2. 2 of the vertices are 0 and 4. So I believe in class, I went ahead and graphed all of these. So 0, -9. So 2, 3, 4, 5, 6, 7, 8. Okay, so this would be 0, -9. And again, there's a couple ways you could do this, but this would be one way. So you're trying to figure out which coordinate would make this one is 0, -9. This coordinate, 0, +5. Right? This coordinate, 4, -7, which I believe is our answer. Or this coordinate, 4, -3. So which one would make a triangle that of an area 16 if our coordinates were 0, 1? So I guess I'll call this E and F. And 4, 1. So this is our triangle. And we notice if we use our magic pen, if I pick B, I get a 4 by 4 right triangle. And the area of that would be 1/2 4 times 4, which would be half a 16 or 8. And that's not going to work. So B does not work. B gives me an area of 8. So let's look at A. If A, I'm all the way down here at -9, and I'm up here. So that'd be 10 by 4. So that'd be 4 times 10 and divide by 2. You get 20. Here my area is 20, so that's not going to work. So let's try C. Here, C, I get a right triangle that's 4 by 2, 4, 6, 8. Ooh, so, okay, that's going to work because 4 by 8, and then I divide by 2, is 16. And that's the one I'm looking for. So this would have an area of 16. Question number 3. If the endpoints of a regular, that means all equal sides, were -1, so I went back 1, up 4, and then 2, 3. So if I had a pentagon and this was one side, what would be the perimeter of that? So you should be thinking here, the shape itself would be equal. Man, I didn't do a perfect job, but there's an idea of what that pentagon would look like. And each side's going to be exactly the same. So we just have to figure out what this one side is. Oops, sorry about that. And we could use the distance formula here or just this invisible right triangle. So we have an invisible right triangle that's 1 by 3. So we get 1 plus 9 or the square root of 10. Now the perimeter of this shape would be all those 5 sides added up. But the word regular tells us they're all square root of 10. So there's 1 square root of 10, another square root of 10. Like you're going to add all these up. So you get 5 times the square root of 10. Question number 4 says a triangle is shown on the coordinate plane. What is the area? Okay, so when we did this one in class, we got 6 there. This is the one that makes the most sense for it. And I want to turn it sideways and make this my altitude. Boo! Splat. So if I'm hoping you're thinking about this shape being sideways. If I rotate this, right, you see how I'm rotating my paper? That's my altitude. So the area of a triangle, I'm going to rotate it back so I can write on it here. So my area of my triangle is 1/2 base times altitude. So the base we said was 6. The altitude, we got to count that. So we got 2, 4, 6, 8. So that's 8. So, oops, I wrote that wrong there. So I get 40 8. Divide by 2, which would be 24. I could also cancel this here, right? 3, yep. And 3 times 8 is 24. So, done. Well done. Page 35. It says, use the geometric shapes and their properties to describe objects, like modeling. Okay, so what is the volume of the CD case? The volume would be base times width times height. 1 times 8 times 8, so 64 millimeters cubed. Nice. All right, calculate the area of a triangle BAT with an altitude AM given these coordinates. Okay, so I need to be able to go back 5, down 3. So this looks about right. All right, so if I went back 5, up 1, 3 and down 3, 1 and up 7, back 3 and up 3. Okay, so it says find the area of this triangle with an altitude AM. So, boo, splat. This helps me see that I can make this my base and that my altitude, and I just went 1/2 base times altitude. Okay, so let's do it. So my base is this, and I could use that trick, right? This trick or the distance formula, that's fine. So it looks like to get from B to T, I go up 2, 4, 6, and I go over 2, 4, 6. So that has to be 6 squared plus 6 squared, and take the square root. Okay. Now, what's my altitude? So I'm going to get my magic pen. What's the distance between here and here? I can just draw in an invisible right triangle to find out. I could draw in the invisible right triangle here as well. It's going to be the same, so whatever you want. So we get 2, 4, 6, 2, 4, 6. Oh, interesting. So this altitude is also this same thing, 6 squared plus 6 squared, and take the square root. Okay, so what's the area? Well, it's 1/2 base times altitude, and the base is the square root of 72, and the altitude is the square root of 72, so that'd just be 72. And we're going to cut that in half. I get 36. Is that one of my choices? Beautiful. Now, I want to talk about, because I talked about this in class, if you are also trying to check your answer for reasonableness, you can count these squares. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. You could count maybe 2 halves, 30, and like this maybe would be 31. A little half and a little half would be 32. Notice how this does also appear just by reasonableness that it's 36 square units. Nice. Question 3, Dylan built a wooden cabin. The cabin is 30 meters wide. He obtained a bunch of 17-meter long wooden beams for the roof. Naturally, he wants to place the roof beams at an angle where each pair of opposite beams would meet exactly in the middle. What should the angle be between the roof beams and the cabin? Okay, so they're asking for this, so I'm going to call that X. We know that we want it to meet right in the middle, so this tells us that those are 15. So I'm going to blow up this triangle here. And you might be wondering, why did I draw that shape? I was bored. I got a little creative. I just drew that 3D shape on there. I thought it was kind of cool. Okay. So We got a right triangle. We know this is 17 and this is 15, and we're solving for this missing angle. Okay, so I'm going to use trig. Opposite my reference angle, opposite my box, and I have my adjacent side, right? And I'm solving for the missing angle. So even though it's not on my trig sheet, I have to use trig oftentimes when I'm solving just describing of objects or modeling type of problems. Okay, so I have something to plug in for hypotenuse and adjacent, so that means I need the cosine. The cosine of an angle is adjacent over hypotenuse, so the cosine of an angle is 15 over 17. So to solve for the missing angle, I need this inverse cosine button on my calculator, because when I take the inverse cosine of 15 over 17, that will tell me my angle. Okay, so let's open the calculator function, 15 over 7. All right, so calculator function, we have 15 divided by 17. I get 0.882, and then I'm going to hit, oh, here's an advertisement, and 0.82, and then I'm going to hit second, so see how it says cosine -1, and then I want to hit, so 28.07. So I get 28.07. It says round to the nearest hundred. So let me just double check I rounded. Yep, the 2 would round, keep the 7 the same. And that's in degrees. All right, last question on this video. Abraham works in a delicious cake factory. The cakes come in cardboard containers shaped like right circular cylinders with hemispheres on top. Abram wants to wrap the cake container completely in colored plastic. What is his surface area? Okay, so this would be very difficult to do without memorizing these formulas, and I don't really have it, but I've noticed on the test sometimes they'll provide them. So the surface area of a hemisphere is 2 pi r squared. Okay. So, or excuse me, 3 pi r squared. So let's go back to our problem. Don't fall for that, right? That's our diameter, so that'd mean our radius would be 5, right? So 3 pi. What I don't know, though, is if it would include that circle or not. So if this formula is just including, like, coding this top part. So I'm just going to play with this. I get 25 times 3 times pi, or 75 pi. All right, now for this rectangle. So we learned in class that this rectangle wraps around the whole part here. So that would, if we open that up, then it would be 4 inches high, but I need the circumference. So the circumference is 2 pi r, or pi times the diameter. So this would be 10 pi. So the area of the rectangular part would be 4 times 10 pi, or 40 pi. So if I add these two together, I get, there we go. Nice work, guys.